that is random variable. So what is a random variable? By definition, random variable is a set of possible values from a random experiment. And random experiment is the one whose outcome is uncertain. For example, we roll a dice. The possible outcomes here are 1, 2, 3, 4, 5 and 6. Now the variable x can take any of these values. Hence x is a random variable. We use random variables because in an experiment there could be n possible outcomes, and mentioning all the outcomes every time we use the experiment is not a wise thing to do. So we use random variable to denote the possible outcomes. Now the probability of the possible outcomes of a random variable is given by probability function. There are two types of probability functions: CDF, which stands for cumulative distribution function, and PMF or PDF. Now in the case of CDF, whether a random variable is discrete or continuous, it is given as fx is equal to probability of capital X, that is a random variable, being less than equal to small x, which means any value of x. Now it could be a uniform or normal distribution, etc. We will learn these distributions in the upcoming slides. We will also see one example of CDF in a while, but before that let's understand what is PDF or PMF. So probability mass function is used when the random variable is discrete. So PMF can also be derived using CDF. When the random variable is exactly equal to small x, then CDF becomes PMF. So here we find the probability of a random variable capital X being exactly equal to small x. So PMF could be a graph, equation, table, Poisson or binomial distribution. Then in case our random variable is continuous, so we use PDF, which is probability density function. Now it tells us the probability of a random variable capital X being not equal to a particular value of small x. Here probability at a particular point is 0. Again, it could be a uniform distribution, normal distribution, etc. Now let's see one example of each of these distribution functions. So first we will see CDF. Say in a group of students, probability is equal to 0.7 is found using CDF at x is equal to 80%, which means there is a 70% chance that a randomly selected student will have a score less than 80%. Remember, it gives us the probability of being equal to or less than x. So that is how we use CDF. Now an example of PMF would be, let's say a company sells 2 homes per day and we need to find the probability if it will sell 3 homes tomorrow. So here we can use PMF because we want to find the probability of a random variable capital X being exactly equal to a certain value of small x. That in our case is 3 homes. So here we can use PMF. And lastly for PDF, we use it in several places. And we will see this in our course throughout. It is used for any continuous variable that follows normal distribution, such as human IQ data, etc. So that was a quick brief about the probability concepts that we need to know right now.